All right, so I'm going to show you how to build a Bioclim model with ENMTools. This is a pretty good place to start if you're sort of new to this, because Bioclim models are very simple and they're very easy to build. You don't have to sort of pick out a background or any of that sort of stuff. And we're just going to use this to sort of show you the very basic workflow for building a model. So first we need to load in the package. There you go. And now if you were working with your own data, you would want to build an ENMTools species object and load in some environmental rasters. But there's another tutorial that already shows you how to do that that's in this playlist on YouTube. And so we're going to skip that for now, and we're just going to use one of the built-in data objects from ENMTools. So in ENMTools, there's this object called iberolacerta.clade. And that's basically just got some information about 7 species. So it's got ENMTools species objects for each of these species, and it's got a phylogeny for those 7 species. But we just want one of those species out right now. So we want the one called Monticola. Oops, that's not the one. There you go. And that's just a nice little ENMTools species object. And just to show you what that looks like, we can use one of this interactive plot function on that object. And that gives us this nice little interactive map here that we can sort of pan and zoom and see what our points look like and what our species range map looks like. And we can turn things on and off and all of that. Okay. So we're going to use this iberolacerta.clade species Monticola object to build our models, because we're only building a model for one species, not for everything in the clade. But we don't want to have to type all of that all the time, so we're just going to create a little object for it called Mont and just sort of pull that Monticola species object out. So it's that same thing. We've just sort of moved it to something that's faster to type, right? So in ENMTools, we've also provided some fairly coarse resolution, small extent environmental rasters, just again for demonstration data. So we'll just to show you the extent there, plot the top layer there. And so this is the first Bioclim layer for this little sort of section of Europe. So we don't want to use all 19 Bioclim layers to model our species. So we're just going to pick a couple. So I'm going to create a little raster stack called env, and I'm going to take Bioclim, and I'm just going to pick out the first and 12th layer. So that's Bioclim 1, Bioclim 12, and we'll plot that real quick so you can see it. So this is just basically, we'll just grab these 2 layers to build a model with. And now we're going to use these layers in env and the species in Monticola or in Mont to actually build a Bioclim model. So I'm going to call this mont.bc. This is kind of my own little naming convention. You can call it whatever you want, but this tells me this is a Bioclim model for a species named Mont. I'm going to call the ENMTools.bc function, and I pass it the species name, and I pass it the environmental layers, and that's all it actually needs. It's already done. So let's look at this mont.bc object. Right, so this has given us a nice little raster map of our species, or of our model for our species. And so here we've got suitability plotted from low suitability to high suitability. The points are in the way there a little bit, but it's a ggplot object, so you can edit it all you want. We can also look at this in the interactive plot function and just see what that looks like. It's getting some warnings here because this is now the switch. I can't remember if it's RGDAL. I think it's RGDAL or RGS to a newer version has created some new requirements for spatial data that we have not quite caught up to yet, but those are not anything to worry about. Anyway, but now we've got this nice little browsable thing here where you can look at the suitability projected onto a base map, and we've got our little training points and stuff like that. So that's all very cool. You can also, look inside that mont.bc object, And there is, if you want a raster, that's actually in here. You can do mont.bc suitability, and that is an actual raster layer, so from the raster package, and anything you could do with a raster layer, you can do this. This is made by the raster package, so it's exactly what you would, it acts like exactly you would expect it to. Similarly, if you want to look at your evaluation statistics, it's calculated those automatically, and these are calculated using the evaluate function in Dismo. So anything you can do with those, you can do with these. So this mont.bc training evaluation object is actually a Dismo evaluate object, and so if you want, for instance, you know, true positive rate or something like that, you can actually just get that out of that evaluation object, right? So you can calculate, I mean, it automatically does AUC and all that sort of stuff, but you can calculate anything you want because that you could do with a Dismo evaluate object, because that is a Dismo evaluate object. So that's very handy. We've also got response plots, if you want to look at those. And those basically show you the sort of marginal suitability predicted from your model as a function of your environmental variable, right? It's pretty cool. And it tells you more than that, though, which is, I think, pretty interesting. So the blue is the predicted sort of like habitat suitability, and this is averaged over the average values for the rest of your environmental layers. So it's this is, you know, Bio 12 is here is 900, but then we're taking the average for Bio 1. So yeah, so these, even for Bioclim things, these can look a little smoother and wigglier than you might expect. That's just because the distribution of the means of the other variables. Anyway, so blue here is your marginal suitability function. Red is the distribution of your presence points. And I mean, this is a Bioclim model, so of course you expect this to roughly follow, the suitability to roughly follow the density of your presence points. And then the green is the distribution, the smooth sort of density distribution of different values of that environmental variable in your training region. So here, for instance, we actually have a lot of presence, sorry, in the species range, which it gets from that range raster. We have a lot of available environment and is lower for Bio 12 than where our species is actually occurring. So there's a lot of habitat that it doesn't seem to like based on these values of Bio 12. And in here, again, we have, this is Bio 1, which I think is the average temperature, something like that. The predicted suitability. So essentially the marginal response of your species at environmental gradient. The distribution of the background. And again, here there's now some higher values for Bio 1 that our species doesn't seem to be hanging out in. And then there's our presence points. Here, the density function for our presence points, which is the red here. So I really like the fact these plots, they allow you to sort of see not just what your model's doing in terms of the marginal suitability, but why. So Bioclim models are really sort of simple. So this is sort of a somewhat limited utility here. But when you get to things that are trying to contrast the presence of your species with the background of your species, sort of looking at the difference in these density functions can kind of tell you a lot about why you get sometimes some strange model behaviors. And hopefully, as I walk through these tutorials, we'll hit a spot where these will turn out to be really informative. Right. And real quick, I'm going to look and see, is there anything else I really need to show you about this? Oh, well, you can get this, right, sorry, that's a raster, so I'll have to plot it. You can get this raster that essentially shows you where your model is being clamped. So by default, we're clamping projections to these models to the minima and maxima for the training region. And this is essentially showing you where your model is being clamped the most, which is valuable to know. And is there anything else? There's other more complex stuff in here that we will get to when we start getting into more interesting model algorithms. One more thing I want to show you. So I showed you we've got this evaluation for these model evaluation objects for the training region. We don't have any for the test region of this because we didn't tell it to do any test data. We could actually do mont.bc is enmtools.bc mont inf. And to set aside some test data randomly, all we have to do is say test.prop equals 0.3. That's going to set aside 30% of our data for testing randomly. So this is that sort of spatially non-structured test data, and it does that automatically. And now if we actually go to our interactive, tiv.plot mont.bc, you'll see that you've got now you've got your predicted suitability, but you've got training points and test points separately, right? Okay, and that's cool, but you've also got mont. So if you go mont.bc, you sort of scroll through here, you'll see a test.evaluation. And this will give you your AUC on your test data, but also all those things that you can get out of a Dismo evaluate object, it will give you on that randomly withheld test data. These are also doing training and test evaluation in environment space. I'm not going to go into what that actually means here. There's this paper I did from 2019 in Ecography where we sort of talk about how this works. This was me and Russell Dinage and Linda Beaumont and John Baumgartner. And these essentially measure how well your model predicts the presence of your species in environment space, with that environment space being bounded by the minima and maxima in your training region. So those are pretty interesting, worth looking into, but too much to talk about just at the moment. One more thing you can do is you can actually do, let's see, we'll do one more time. Oops. I think the command here is block. Let's see. Yep. Okay, so interactive.plot mont.bc. And what this is going to do is this is going to use a block cross-validation. Ooh, we are way zoomed out. Hold on a second. Zoom in here. And so what you'll see now is that our training points and our test points are sort of spatially segregated, right? And so what we've done is we've essentially used block CV. We've taken one corner of the data out. We've built the model with the other three corners and seen how to see how well it predicts this corner. And that's often a much stricter test of how well a model is fitting your species distribution. So let's look at what happened to our test evaluation stuff from that. It's still actually not so bad. So our test evaluation based on the block is 7.02, but it was 0.72 when we had random holdouts. And so it went down a bit, but often it'll go down quite a bit because it's a much sort of stricter test about of how well your model predicts some other data. Okay, so that's just kind of the quick and dirty look at how you build a simple model in ENMTools. Like I say, you need to build a species object first if you're using your own data, and you'll probably want your own environmental rasters as well. There's another tutorial on how to do that. But great, hopefully that was helpful.